All right, let's talk about a true legend in the software world, Jenkins. You've probably heard of it, you might even use it every day. Today, we're going to pull back the curtain and see what really makes it tick. We'll look at its core architecture, how it automates pretty much everything, and how this OG tool is still a major player in the modern cloud era. Let's dive in. You ever notice how some of the apps on your phone just get better? Like, one week there's a cool new feature, and the next, another one appears. And then there are those other apps that seem to crash all the time and haven't been updated in years. Well, the difference isn't just luck. The secret sauce is a process called continuous integration and continuous delivery, CI/CD for short. It's the engine that powers modern software development.
And that really gets to the heart of the modern software problem. It's this constant battle, right? On one hand, you have to innovate and push out new features at lightning speed just to stay in the game. But on the other hand, you absolutely cannot break things. Your users expect things to just work. It's a serious tightrope walk, and messing it up isn't really an option.
So how do the best teams manage this? Well, let's look at the two ways to release software. There's the old way, which was, frankly, a nightmare. It was all manual, painfully slow, and just begging for someone to make a mistake. But then there's the CI/CD way, and this is a total game changer. It's all automated, it's incredibly fast, and it is way, way more reliable.
The foundation of this whole new approach is something called continuous integration. And the idea is actually pretty simple. Instead of developers working in silos for weeks and then having a painful merge day, they're constantly integrating their code changes into one central place, multiple times a day. And here's the magic part. Every single time they do, a whole suite of automated builds and tests kicks off instantly. This means you find problems in minutes, not weeks later when nobody remembers what they did.
Okay, so a great strategy like CI/CD is one thing, but you need a tool to actually do all that work, right? You need an engine to power the whole thing. And for millions of developers around the world, that engine is Jenkins. It's the workhorse that drives the entire process, from the second a developer commits a line of code, all the way to it getting deployed.
So what is Jenkins really? At its core, it's this open-source automation powerhouse. It's built on Java, and because it's open source, it has a massive, super active community. But its real superpower? The plugins. There are thousands and thousands of them, which means you can make Jenkins talk to pretty much any other tool out there and automate almost any workflow you can dream up.
And when I say it's popular, I'm not exaggerating. Get this, a whopping 54% of developers rely on Jenkins for their CI/CD needs. I mean, just think about that for a second. In the tech world, tools pop up and disappear overnight. For one tool to have that kind of dominance and staying power, it tells you just how powerful and flexible it really is. But here's the thing that people sometimes miss. Jenkins is so much more than just a CI/CD tool. Oh yeah, you can use it for your CI and delivery pipelines, of course, but you can also use it to automatically deploy your infrastructure. You can use it to run scheduled nightly reports. You can even use it for simple ad hoc stuff like database backups. It's like the Swiss Army knife of automation.
So how on earth does one tool manage to do all of this so reliably? Well, the secret is its incredibly elegant and powerful architecture. It's all built around two key parts that work together perfectly: the Jenkins master or server and its agents.
First up, you've got the Jenkins server. The best way to think about it is like an air traffic control tower. It's the brains of the whole operation. It holds all the plans, the configurations, the plugins. It orchestrates everything. It knows what needs to be done and when it needs to happen. But, and this is the most crucial part, it doesn't actually do the heavy lifting itself. So, who does that heavy lifting? That's where the Jenkins agents come in. If the server is the control tower, then the agents are the worker bees. These are separate machines that get their instructions from the server and then carry out the actual work. An agent can be a physical server, a virtual machine in the cloud, even a container. They're the ones compiling the code, running the tests, and doing the deployments. And this separation is pure genius. This is what makes Jenkins so scalable. The server doesn't get bogged down with a ton of work, it just focuses on being the coordinator. This means you can have a whole fleet of agents running dozens of jobs in parallel. Maybe you're testing on Windows on one agent and Linux on another, all at the same time, and the server just keeps things running smoothly. So, how do they all talk to each other? Well, there are two main ways. The first is pretty straightforward. The master reaches out and starts a connection to the agent, usually over SSH. Simple enough. But the second way is really clever. It's where the agent actually initiates the connection back to the master. This is a lifesaver if your agent is sitting behind a firewall or in a network where the master can't easily reach it.
Now, getting Jenkins up and running is one thing, but building a setup that's truly high performance, stable, and ready to scale, that's a whole other ballgame. So let's talk about some of the most common traps people fall into and how you can avoid them, with some advice straight from the experts.
You know, according to these experts, it's actually pretty easy to tell when a team is heading for trouble with their Jenkins setup, and it almost always comes down to a few key misunderstandings about how the architecture is supposed to work. And these aren't small issues. They can lead to major performance problems, instability, and a system that just frustrates everyone.
So what is the #1 most important rule for building a Jenkins setup that will actually scale? It's this simple, and it's absolutely non-negotiable. You have to use agents. Running your builds directly on the master server is the single biggest mistake you can make, and it's a recipe for disaster.
In fact, here's the real pro tip. The golden rule is to go into your Jenkins controller configuration and set the number of executors to 0. Yep, 0. This makes it physically impossible for any jobs to run on the controller itself. It forces everything out to an agent, which protects your control tower, keeping it stable, responsive, and ready to orchestrate your pipelines.
This master agent architecture has been the heart and soul of Jenkins for years. But the world has changed. Today, it's all about containers, microservices, and the cloud, which brings a whole new set of challenges when it comes to scale. So how does this veteran tool keep up? It evolves. And today, one of the most powerful ways to run Jenkins is on Kubernetes.
Think back to our air traffic control analogy. What happens when you go from managing a few dozen flights an hour to suddenly managing thousands of them, all taking off and landing at once? Your simple control tower just can't handle it. You need a completely different system, one that's dynamic, automated, and incredibly resilient. And for Jenkins, that system is Kubernetes.
And running Jenkins on Kubernetes is just a massive upgrade. You get things like dynamic on-demand agents. A build kicks off, and a new agent container just spins up out of nowhere. The build finishes, and poof, the container is gone. It's unbelievably efficient. Plus, you inherit all the other great things about Kubernetes, like high availability and self-healing, which makes your whole automation platform more resilient than ever. So when you step back and look at it, from its timeless master agent architecture to its modern evolution on Kubernetes, Jenkins has proven over and over that it's an incredibly adaptable tool. But software development is only getting faster and more complex. So it leaves you with a really important question to think about. Is your automation strategy ready for what's coming next?